I want to welcome you to Waste Heat Recovery. This is going to be talked about and investigated by Miriam and August.
So in what industries is waste heat recovery applicable? The general template for where we can apply waste heat recovery is we have an industry which has energy input coming from coal, gas, nuclear, or renewables, and we use this energy to heat something up in some sort of heat process, whether it's for steel manufacturing, for cement, glass, and we end up with some product. And what the heat process is and the product doesn't really matter. What matters is that this heat process has a lot of heat exhaust. And traditionally in these industries, this heat ends up just dispersing into the universe. The idea of waste heat recovery is we take this heat and reuse heat, which is energy, for something else. One of the main ways is we can reuse this heat to preheat something. Not preheat something, but generally just heat something up. We can use it for preheating, we can use it for heating water, heating a facility, and we just use it in the form of heat. Or we can transduce this heat back into electricity and keep this electricity on facility, or generally just we're keeping this energy, not allowing it to be wasted into the universe. Hence, we recover the energy. This ultimately will decrease the amount of energy input required into the industry, into the facility that is using this idea.
There are 4 ways to analyze waste heat recovery systems. The first way is called HRV, which stands for Heat Recovery Ventilation. Another way to analyze would be called CHP, Combined Heat and Power Systems. The third way is called EMS, which is Energy Management Systems. The fourth and final way is called DHC, which stands for District Heating and Cooling. HRV. It stands for Heat Recovery Ventilation Systems. Keeping that in mind when we design heating and cooling systems for commercial buildings or government buildings or any big buildings, we try to maximize all the energy from it. And we can investigate different types of technology, such as rotary plates, heat exchangers. EMS, it stands for Energy Management Systems. It is a comprehensive framework designed to monitor and control and optimize the performance of energy-related assets and processes within an organization. The primary objective of EMS is to enhance the energy efficiency, reduce the consumption, and consequently lower the operational costs. There are 10 parts of EMS. The first part is monitoring and analyzing. The second part is data collection and visualization. The third part is animation and control. The fourth part is demand and response. The fifth part is integration with renewable energies. The sixth part is compliance and reporting. The seventh part is energy conservation and measures. The eighth part is cost saving. The ninth part is environmental impact. The 10th part is continuous improvement. Automation and control enables various energy consumptions in the system to be optimized and for the operation to be on a demand factor. This is very helpful for a lot of HVAC systems. Demand response to changes in the energy demand, allowing organizations to adjust the energy usage during the peak times or based on fluctuation on what processes are happening. Integration with renewable energy helps organizations take in sources of energy that are less harmful for the environment. EMS can help manage where that energy could be used to overall optimize the system. EMS solutions assist organizations in adhering to energy-related regulations and standards. They also generate reports to track performance and energy saving and compliance. This is important for a lot of major companies that are building, or you might have a power plant and there's a lot of government agencies that require certain criteria based on energy consumption.
District heating and cooling, or DHC, is a type of waste heat recovery heat reuse that incorporates the waste heat from industrial processes and power production and data centers into the local heating and cooling systems for reuse.
So for heat exchangers to give off that energy, we model it with the equation with respect to X, Y, and Z, which there's diffusion, there's time that it usually takes for the heat to get transferred, and the area. Now, so we can analyze this in a less complex way, we create a model that is a standing steady state. And by doing this, it causes the PVE to become an ODE by making constants. So the time, when you take the derivative of a constant, it goes to zero. So time goes to zero, and then you also have the diffusion goes to zero. So all you're left with is area. To spare you guys the effort, the equation boils down to this. So you have the change between the temperature of the surface and the temperature of the fluid around the fins, which in our case is air. And then you have the area of the fin, which gives you the amount of energy that can be pulled off by the fin. Waste heat recovery, it will result in relentless pursuit of knowledge in thermodynamics and heat transfer. Will undoubtedly lead to groundbreaking innovations and new research, and innovators will continue to explore novel materials and methods for more efficient recovery, including in advancements in thermoelectric materials and cutting-edge technology. In the grander scheme, the concept of a circular economy, minimizing waste and maximizing resource efficiency, will guide industries towards investing in heat recovery. This strategy aligns seamlessly with broader goals for sustainable resource management, marking a paradigm shift towards a circular and regenerative approach. In conclusion, the future of heat recovery is an exciting frontier defined by technology innovation, heightened environmental awareness, and the integration of heat recovery systems into the core of our energy infrastructure and industrial processes. As we collectively focus on energy efficiency and reducing carbon emissions. Heat recovery stands as a vital pillar in achieving these goals, paving the way for a more sustainable and resilient future. Thank you guys for watching our video.